Okay, so next stage on changing the timing belts on the Lotus Esprit V8 and doing the Scotch key mod for the intermediate to the shaft timing gears here. The jig has arrived, so I'm just about to put my flywheel locking tool on the flywheel here. Obviously, let's lock that up. It's the thing about YouTube, isn't it? It's doing everything one-handed. I won't be doing it all one-handed. But let's do this up anyway. Okay, so that's locked the flywheel up properly, and obviously the crank and everything off the auxiliary shaft. Everything this end. I mean, the timing locking tool is still in there, but you don't want to be torquing things up, just relying on that to secure the crankshaft location. The pins are still in the camshafts, so the timing is preserved there as well. So loosen off timing tensioners. Come on. It did loosen. Yeah, there we go. So of course you'll need one of these timing gear adjustment tools. But I'm sure these are, yeah, I mean that one's quite loose. There we go, that's nice and loose now. I should have done that by hand, but I mean you're going to need the tool to tighten up timing belt tension and check the tension with your Clavis tool or the equivalent on your smartphone. Okay, so let's take the tensioner right off. I've already got the belt off actually on that one. So the tensioner comes off, and we can now remove the timing belt. A little tight down there, isn't it? There we go. So let's not get them mixed up. We've got new timing belts on top, old timing belts down here. So over by the bin. Let's take the other tensioner off. I will be taking off the water pump and the power steering pump, which is here. Water pump, power steering pump. This is the AC compressor down here, and also the tensioner for the auxiliary or serpentine belt, some people like to call it, because I'm going to be drilling here with the jig, of course. Right, another belt off. Old belts. Okay, so just detorquing the timing gears on the intermediate shaft. I know it was torqued up to spec, but it's not. I mean, I've got a fairly long breaker bar on there, but it's it wasn't that. It was a little bit tighter than that, but it wasn't super tight. Like I say, I think Lotus say they've never had a timing gear become detorqued on a production engine. But when you're pushing this engine towards GT1 specs with the extra NVH, noise, vibration and harshness that you're likely to get with all the oscillations and harmonics, you know, you can expect things to suffer. Bolts could become detorqued, and I know that's happened to people on the forums, probably where it wasn't torqued properly. But anyway, can carry on with this now. Okay, so there's the bolt and washer. And well, the engine's locked up, isn't it? Look, and here's the problem, like you can see. There's the two banks of the cams moving totally out of time with each other and completely out of time with the locked crankshaft, which isn't rotating because it's just on this shaft here. Okay, so let's take these pulleys off. I've actually got pulleys from the Motorsport, the GT1 program, which have got this shoulder for retaining the timing belts. That's another nice little extra this engine has. There's a pulley, there's a washer in between which will be drilled as well. And then there's the rear pulley. So I didn't need to take them off. But I don't know. YouTube's for showing things, isn't it? So here's the intermediate shaft, and like I said, it's driven by a timing chain behind this casing. Point of note for the drilling that needs to happen, we need to register the depth properly. See what I can arrange with my drill, because you know, obviously there's an oil seal on the IMS, as people like to call it, the intermediate shaft, the intermediate timing shaft here. We don't want to drill into that, so we'll be drilling into the wheels themselves, the gears themselves. You could call them sprockets, but I normally use that term for a chain drive, whereas this of course is toothed belt drive. Let's just reassemble that now. Okay, so right, so there's a flat on one of these bolts here. Yeah, there we go. So we need to arrange. You can drill this hole anywhere. Just shown that better, shouldn't I? That it's going to go through the alignment of it. We'll end up with a hole that's half in the shaft and half in the gear. I could give you a shot with my optic fibre camera. I keep just calling it optic camera, which is pretty obvious. And I've worked in the IT industry as well, so I should know about optic fibres. But yeah, it will be half in the gears and half in the shaft, so it will preserve the timing and locking. Okay, right, I'm just double checking everything before starting drilling. So I've got the jig on there, obviously without the gears. I'm just measuring the depth to that shoulder on the IMS timing shaft there. I've got a paint mark on my pointer to measure depth there. So I don't know if you actually would drill into the oil seal. It's more like start drilling to that shoulder, but I mean you don't need that much depth. You just need to be significantly into the second pulley. I'll do some measurements. Right, okay, so I've got the pulleys on top of a piece of alley bar here, just as the bottom register, with the jig in place. So we should see the measurement line up the same. There's the paint mark that I put on my depth gauge there, so let's get this in the right place, and yes, there we go, so same measurement. So that's the equivalent of me going up onto that shoulder on the intermediate shaft. So I've just done a still to measure this properly. So I will, I'll put a still in to show that. Sorry, this is fiddly. It's looking like 50 mil, 5 centimeters, 50 mil, just under. The paint mark is not super accurate, but obviously I'm going to leave an overhead, like I said, so the depth is not too much and also not insufficient. Right, now one thing that I am a bit concerned about is the alignment of the drill longitudinally along the shaft. Now the jig it's got some depth to it, so if the drill was a good fit, it would align it quite well. I mean, I'm sure this is really a job for the shaft being out and on a milling machine, or if there's some way to put a bed on the put a clamp on the bed of a lathe and use a drill in the lathe, and you accurately drill. This is an easy way to do it, but trying to find the right size drill, I'll have to check what's recommended with this, but so far a 6mm drill is in place here, but you can see what I mean, there's quite a bit of movement, and it's not a very good fit. I've got a new set of metric drills here and an old set of imperial. Now there's one drill size up to a 6.5mm, which would be great if that 1/2mm was a perfect fit, but no. So that's a shame. I must think that well, let's see what happens. But same with metric set. If I go to 15/64, yes, we're in, but again, I think it looks worse, but the drill is slightly bigger if you compare the shaft diameters on it. And if we go up to 1/4, yeah, that's right, because 16/64 would be a 1/4. Anyway, the next drill up is clearly a 1/4, but again, doesn't fit. There's a maths thing for you. Reduce. No, I'm right. 16/64 would be a 1/4. The ratio of 1 to 4 there. So 15/64 is 1/64 smaller than a 1/4. There we go. But anyway, for my problem, or situation I don't really like, I'd like, well, let's be modern. How long have we been using metric? Well, especially in SI units in science, even longer. I want the 6.5mm drill to fit, really. So, well, that's a shame. So I'm not ready to go ahead at the moment, so we'll see what happens.